Alright, our next video is over conditional statements. And I cut this straight from your book, your textbook, because I think your book does a really good job of explaining conditional statements. So while I'm not always a fan of reading to you, I think that their words are the best way to describe this to you. Conditional statements. A conditional statement has a hypothesis and a conclusion. An if-then statement is a form of a conditional statement. The if part contains the hypothesis. The then part contains the conclusion. So when we look at this whole sentence, we're going to call the whole sentence the conditional statement. And if A is a positive number, then the absolute value of A is equal to A. Hypothesis is the idea, the if, and the conclusion is what we think will happen. So in mathematics, if-then statements are either true or false. If an if-then statement is true if the conclusion is always true when the hypothesis is satisfied. An if-then statement is false if, for just one example, called a counterexample, the conclusion is false when the hypothesis is satisfied. So when we look at this, what we're really looking at is a couple of pieces. We're looking at the if, the hypothesis. We're looking at the then, the conclusion. Normally we would expect the if to cause the then to always be true, which is pretty often. If we say, well, that's not true, the reason we only need one is called a counterexample. Let's look at this in practice here. If a number is an integer, then the number is positive. So we need to identify the hypothesis and the conclusion, then tell whether the conditional statement is true or false, and if it's false, we have to give a counterexample. So we look for that word if, the hypothesis, if a number is an integer. So fill it in. Then we go to the then part, then the number is positive. So the conclusion is the number is positive. So now we have to talk about whether or not this is true or false. The number is an integer. Remember, the definition of an integer is that it's either negative, 0, or positive, but it's got to be a whole number. It's got to be a counting number, per se. Well, didn't we just answer that? The number is positive. Well, integer implies that it could be negative as well. So we know that this is false, and our counterexample is to just pick one. Let's pick -6 is an integer, but not positive. And we've provided a counterexample. This is kind of an easy idea, but it's a new idea. On the next page, you'll find example number 2. Why don't you go ahead and give that one a try? I'll give you a moment to fill it in, and then I'll put the answer up, and you can check and see how you did. I'm fairly certain that you'll be very confident in this one. It's not a tough concept. So go ahead, turn to page 2, give it a try. Alright, here's your explanation. If a number is negative, then its absolute value is positive. The hypothesis the number is negative. The conclusion, its absolute value is positive. Hopefully you can see right away that this is a true statement, which means that we do not need not applicable. Counterexample is not needed. Those are our conditional statements.